So far, most of the methods that we've looked at throughout the course have taken a primitive data type as its parameters. And when we say primitive data type, this means things like the int and the char. However, we can use objects as the arguments for methods as well. Let's show some examples. We're going to redo this home area calculator class. So I made a new one that's called home area calculator redo. And we're going to create two instances of the rectangle again as rooms, but we'll make this a little bit more understandable. So we'll say rectangle, and we'll call this one kitchen. And we'll make a call to a method we haven't defined yet called getRoom. So we're going to clean things up a bit. And let's make one more rectangle. We'll call this bathroom and also call the getRoom. Okay, so let's go ahead and define this getRoom. And we'll say public. And this method is not going to return a primitive data type. It's going to return the rectangle object because that's what we're expecting from getRoom. So we see we don't have to limit our methods to the data types that it returns being primitive, nor the parameters that it accepts. And we'll call this getRoom. Now inside of here, let's just go ahead and prompt the user this time to enter the length and the width of their room. I'll type that really quickly. Notice here, let's highlight this scanner. We've been using this all along, and now it should look really familiar to you what we were doing. So the scanner is a class that's already defined in Java. We are using this scanner as our object name. We're using new to instantiate this, and we're calling a constructor that takes in this argument. Now we're going to go ahead and import this. Now notice we had to import the scanner class, but we didn't have to import the rectangle class. Why is that? It's because if we look over here, rectangle is in the same package as this home area calculator redo. So for classes that are within the same package, you don't have to import them. However, this scanner belongs to java.util package, and because it's a different package, that's why we have to go ahead and import it. Now remember in the last chapter, when we talked about methods, I told you that a method can only return one value. And we even had a case where we had two values that we wanted returned, but we had to split that method up. Now that we're using objects, we no longer have to do that sort of thing. So we can have this length and have this width, and it's part of an overall object. So we're going to return one value back, but that value happens to be an object that contains lots of different data. So that's a really good perk. So we're going to create this new rectangle, and actually I'm going to show you something new. So I can create this whole rectangle how we've done in the previous section, or I don't need to store this. If I created this, let me show you. I can do this and I can say return room. And the return statement has to be the very last thing. So we'll say return room. This is perfectly fine. However, we are declaring this new object and we never use it again except for right here. So it's kind of a waste to store this in this space. Instead, we could do a little shortcut and just say this. So we don't have to assign it. We can instantiate this and then return it like this. That's legal as well. Now we have our getRoom method, And we're making a call to this good room method. However, it's complaining there's a compilation error. If we look at this compilation error, it's saying that the non-static method getRoom cannot be referenced from a static context. So far within our classes, we've been using this static void main. Now, main has to be static. That's the way Java is built. However, all of our other things don't necessarily have to be static. And now that we've talked about classes and objects, we can talk a little bit more about static. Static is used when you don't want to create a new instance of that class, but yet you want to access the things inside of it. So it has no state. If we look at, let's look at our class from a little while ago. When we set this width and we set this length, we've now set state for room 1. So when we want to call calculate area, we didn't have to pass in any additional information because we've already set this up as state. So we can make subsequent calls and it's keeping track of all the data that we've already set for this object. In a static context, there's no such thing as state. So you're just calling to a method itself. If we don't want to use static and we want to keep state, then what we would need to do is create an instance and then call the methods. Now we're within this same class, but in order to call getRoom without making getRoom static, we would have to instantiate the very class that we are in. So let's do that above here. And we'll just say, we'll copy this. And we'll call this calculator. And equals new and paste this. Now that we have that, we can use this object and say dot. So we've created an instance of the very class that we were in just so that we could get the things that are not static within this class. Notice something else that we've done here. We've instantiated this new calculator redo by calling this constructor. But there's no such constructor defined in this class. That's because in Java, a default constructor is always defined implicitly. So even if you do not declare it explicitly, you didn't define it anywhere, it still exists by default under the covers. And essentially what it'll look like is just be a little blank constructor that does nothing. Okay, so now we have our kitchen and we have our bedroom. Let's go ahead and calculate the area. So we'll say double area equals, and we'll make a call to yet another method that we're going to define. And this method is going to take 2 rectangles. So let's go ahead and define that method now. And this needs to return a double. And it needs to accept rectangles. So we'll say rectangle, rectangle 1, and rectangle, rectangle 2. So inside of here, now we have 2 objects that we've accepted. We've declared these as our parameter list. And now we can use the dot operator how we see fit. So we want to calculate the area. The area is the area of this rectangle plus the area of this rectangle. We're going to use our shortcut again and just say rectangle 1 dot calculate area plus rectangle 2 dot calculate area. And this is complaining again because we did not use our calculator object to access this non-static method. Okay, so now we've done the area. What we can do now is just print it out. So let's do that. Okay, and let's give this a go. And we'll say 30, 25. Ooh, we got an exception here. So this is because this scanner object, we've called this twice. So the first time we called this, it instantiated this, it did all of this input, and then it closed this. But when it closes this, it's also doing something advanced with this system.in. And so in order to fix this, we need to just only close the scanner one time throughout our entire program. So this needs to be global if we're going to use it in multiple places. So let's do that. And then let's move this to the very end here. It's not static. So what do? We have to say calculator.scanner. So this is not only used for the methods, it can also be used for the fields, which in this case is also an object. Let's make this private. Okay, so let's clean this up. And let's run it again. Ooh, fun, we got our first bug. Okay, let's try it now. 30 and 25. And let's see, 50 and 75 and 4,500. Okay, so good. In this section, we learned about static and we learned about using an object as return type and also as parameters to a method. Great job.